The first device you might be able to call a pocket watch was theorized by an Italian clockmaker in about 1460. Sadly, they were not ready to start making clocks that small or portable. Aside from just shrinking clocks, we also had to figure out what a portable clock looked like. You might think it's obvious, but look at this ball clock. That's weird, right? Although I'm sure rich folks loved being able to tell the time, what I'm sure they loved more was looking fancy while doing it. So in the 1600s, when waistcoats are popularized, the design of pocket watches had to change to fit with waistcoat pockets. That's where we get this smooth, easy to insert and remove style pocket watch, which is still known today. At least that's what legend says. There's actually a surprising amount of unclear history around pocket watches, forgeries and stuff, but it's something like that. In the 1800s, we see companies like the American Watch Company show up, and they use new manufacturing techniques which allow the price of these watches to drop. And of course, over the next 100 years, they just get cheaper and cheaper. Around the same time, a Swiss watchmaker was hired to produce the first mass-produced wristwatch for the German Navy. Just kidding, that's another watch lie. The watches which were purportedly made for the Navy are clearly newer than they would have had to be for this to line up. But what we do know is that by the World War, trench watches, a modification of a pocket watch, were quite common, and those soldiers probably came back and ushered in the generation of wristwatches which followed. It was only a matter of time until the movements, the mechanical bits of the watch, got small enough that women started wearing them as well. In World War II, we start seeing a lot of photos of women wearing wristwatches, and it seems like at this point, the brief stint of pocket watches being affordable and preferable has ended, and this is kind of the end of the story. The pocket watch has just kind of declined in popularity ever since. But this is also where things get fun, because I get to just start making up an alternative history. And today, I want to imagine a world where the pocket watch had stayed popular into the 1980s, but not our 1980s, maybe a little bit more of a cyberpunk, a retro-futuristic 1980s. I want to take elements from things we know, the vibe of a Casio watch, maybe the plasticiness of electronics from around that time. And that's what I'm going to try to build in this video, a pocket watch that could be out of this alternative history. But enough talking, enough dilly-dallying, enough swaggling. Let's make a watch. With the boss here to supervise, we can dive into this. So I know the screen is probably going to be round, and we're going to fake like 7-segment display numbers on it. I don't want the whole thing to be round though. I kind of want that circular display held in a boxier frame or shell. The screen should lay flat with this shell, and then I want like a 3-dimensional bezel that comes up to give it a little bit more of that like 80s or 90s watch look. The parts of the shell which aren't filled with the screen, I'm going to try to keep as hollow as possible, so you could clip a carabiner on there or attach a little lanyard. And then on the top left, there'll be a button similar to the button on a classic pocket watch that would open the case. This one just turns the device on. Now, about that display, I have the perfect one in mind. It's a Seed Studio round display. If we crack this boy open, you'll see not only is it a small round screen, around the back we have a port for a rechargeable battery, a socket for a microcontroller, we have a backup coin cell for the real-time clock, then we also have an SD card slot, and a power switch. Almost everything exactly right to make a watch. We'll have to customize a bunch of this, but this is a fantastic starting point. For that button in the top left, we'll just have to go look at a collection of buttons and figure out which one has the right sizing. Then I will draw the battery, which we'll need, probably a very small battery, but we'll talk about that a bit more later. And then finally, we need a brain. We're going to use a Seed Studio Xiao. At this point, every project on this channel is using a Seed Studio Xiao. This one is an RP2040, costs like $3 or $4, and it pairs perfectly with that round screen, so those are going to go together awesomely. I like the broad strokes here. I think when we go into the 3D model, I'm going to have to put a lot of effort into little bits of geometry that really sell this as a complete item, but this is a great base to work on. Every time I do a project, I want to pick one skill that I'm kind of focusing on to get better at throughout that build. Other ones, it was circuit board design. This one, it's definitely 3D modeling. If you've been around the channel, you know I've done every project on this channel using Tinkercad, which is an online CAD tool for mostly grade school children. I think I've finally outgrown that tool. So I'm going to dive into Fusion 360. Never modeled anything in Fusion, don't know anything about it, but people seem to use it. So I'm going to learn it. I mean, how hard could it be? Alright, in 8 days, I have watched Learn Fusion 360 in 30 days, and I produced one little piece. Yuck. Oh, that's too much zoom. Bring me back out. It definitely took me longer than I wanted, but I ended up with something that's at least reminiscent of our sketch. The reason it's taken me so long to do anything in Fusion is because it is a totally different mental paradigm than what I'm used to. Let me explain. Let's compare Blender, Tinkercad, and Fusion. Each of these has a very different mental model about how you create something in 3D. Blender is a predominantly polygonal modeling tool. Tinkercad uses constructive geometry, and then finally Fusion is a parametric modeling tool. Let's say we want to make a 10mm tall cube with a hole in it. In Blender, we'd start with a cube, scale it to the height we want, then we would add a cylinder and a Boolean modifier onto that cube. If we select the cylinder, these are now kind of linked, there's no difference in the cube yet, but once we apply that modifier, we can see we've now cut a hole into that cube, and we can actually delete the cylinder, we don't need it anymore. Now the important part to understand is this is now set in stone. The polygons of the cube have changed, and if we wanted to do something like change the size of the hole or reposition it, we would have to do a completely different operation to do that. Now compare this to Tinkercad, same kind of start, we add a cube and then we scale it down, add a cylinder, but this time we're going to set the cylinder to be a hole, then we'll combine it with our cube to end up with our final shape. However, I made a mistake. Our cylinder doesn't go all the way through the cube, but now I can just double click on it, adjust the cylinder, and now it's exactly what I want. It's saving both of those core primitives and constructing a new geometry based on that. Importantly though, Tinkercad is still thinking only in 3D. Now in Fusion, we start with a 2D sketch. In this drawing, I will create a box and I will add parameters to it, which are the dimensions. I'll add a circle inside of that box, and then to turn this into something in 3 dimensions, I'll go into a different mode and extrude that shape up, and there's our shape. Similar to Tinkercad, this isn't non-destructive. We can step backwards in a timeline of operations to get back to our sketch, and we can do much more powerful things like add fillets or rounded edges, and that is just another element in the timeline, which is also non-destructive. We can roll backwards and forward and make changes. Now, none of these are really better or worse, they're all different. Blender is going to be better at organic shapes that maybe you can't describe with a sketch and a number. Fusion is going to be better at things that are mechanical or where pieces have to fit together. And of course, Tinkercad's going to be best for beginners like me, who just needed some way to make something in 3D and didn't necessarily need an overwhelmingly powerful tool. So now you might be able to see how this shape is not that different than the cube we were just messing with. I pretty much made a sketch and extruded it up. Now, in theory, this rounded hole would hold the screen perfectly, but in practice it holds nothing. So I'm going to make some adjustments to the sizing of this model and reprint it. Alright, I lied. I did not make any adjustments. I got distracted thinking about the other big confusing element of this watch, which is how am I going to adhere the front bezel. Imagine this is an oversized version of our bezel. The screen would sit in this hole in the middle. Then to hold it down, these threaded legs would push through the shell and be screwed from the other side. I don't know if that makes any sense. Let me try again. So imagine this ring is the center ring in the shell and it goes all the way through like the one I'm holding. The screen would sit in the middle and then these little alignment pegs would slide between the legs of the bezel. Then we have the third piece, the back, which lines up with the threads on the legs, and we could screw that in, and the whole thing would be held together perfectly, and the screen would stay in place. In theory, anyway. Obviously, this bezel is way too big. This screw, everything is badly sized, okay? It doesn't look like the drawing. I'm gonna go iterate on this, but in the meantime, let's talk about some of the electronic stuff. So I think I got everything we need for the electronics part. We have the screen that we've already shown you. Then batteries. I got the tiniest little battery. I was hoping if I got the right size, it could fit behind the screen. And it does look like this one's going to be just about the right size to do that. So that's fantastic. We're going to need components to replace this on-off switch, because what I want is when you press the button on the top of the device, it turns on the entire thing, so it has no power before that. If we're entirely cutting the power, that means in order to keep the time, we're going to need a backup coin cell battery to keep the real-time clock on, regardless of whether the main battery is connected or disconnected. So we'll grab one of those. I also got these male and female JST 2-pin connectors. The one on the battery is the wrong size, so we'll need to rewire it to use one of these. Then for the button, I grabbed grabbed this variety pack of like 25 different kinds of buttons. I thought maybe this big one would make sense because it was kind of close to the size, but I figured it was better to go with a very common, normal 6mm size button. It'll give us the most wiggle room to work with and build around. So we're just going to grab one of those. This one happens to be blue, but it's not going to matter because we won't see it in the end. I'll also grab 2 more of those JST connectors. We'll use those to wire the buttons so we can remove it and replace it if we want. And that's all our electronics, sans the Seeed Studio Zhao, which we'll just plop in at the end. Let's tackle the power button first because that's the most complicated element. We're going to need to remove that old switch. If you're going to try to do something like this, I very much recommend you doing it with proper tools and not just the nearest sharp thing you happen to have. Because what might happen, and I'm doing this purely for educational purposes, is you might rip the switch off, and when you do that, you might destroy the metal pads you need to solder to. Now you can see, for educational purposes, obviously, I have ripped the switch off, and in that process, I have destroyed the metal pads I would need to solder to. These 2 little gray marks, they should be shiny if they were metal. So in this situation, what you can do if your board is open source like this one is you can pull down the PCB layout and try to figure out where that pad actually was wired to. Zooming in and looking at that pad labeled number 2, we can see it immediately goes up to what looks like another pad for a resistor. So in real life, if we go and find that resistor, we should be able to solder to that point and everything will be okay. The thing is, those resistors are small. The pad we were trying to solder to was already fairly small. This is really small. But you know, gotta crack on. It's already broken, can't really get much worse. So I gave soldering to that little contact a try. And I mean, if you're thinking, Abe, I can't see what you're doing, don't worry, I couldn't either. That thing is so frickin' tiny. But it seemed like I got it. I mean, it's on there, it's pretty firm. So I busted out the multimeter, I checked for shorts, and then I also wanted to see if it was connected to the wiring net the way I expected. So you can see my prongs are like on opposite sides of the board, because if we follow that wire on that PCB, it goes all the way up to a little resistor up here, and that was the easiest place for me to touch and be like, yep, it is connected as we expected. So yeah, I think we might have salvaged the mistake I did for your education. So we'll see when I actually wire up a battery, but let's move on. I said we'd use a standard 6mm button. I tricked you by lying, haha. Instead, we're using a slightly smaller 4.5mm button. It's a bit easier to drop, which is a desirable trait in a button. A quick solder job will get us connected to that connector we just connected on the screen. I've also been experimenting with ways to mount this button. So I have this little tubular thing that it can sit down in, and it presses in, and it's got room for the wires to come out. You'll see why this is important momentarily. But with that, button ready to go. No, wait, I gotta snip the nibs. Snip, snip. Yes, now we're ready to go. Finally, got to sort the battery. The only thing wrong with the battery is that the connectors are wrong size and we got too much wire. So I'm just going to splice in a shorter, smaller connector. And when I do this, I'm going to be careful to cut only the red and then only the black so I don't accidentally short them together. And you'll see I'm also doing them offset a bit so that even if they were pulled tight together, they're not going to touch and short out the battery. To be extra safe, I wrapped each wire independently in some tape and then wrapped that bundle together. So now we're nice and stable. So we got our modified screen, our button, and our battery. That is all we need on the electronics front. Let me show you what our 3D printing department has been cooking up. They've been cooking up a lot of mistakes, or you know, a lot of iterations if you want to be optimistic. So in chronological order, the first one of these is probably this one. It's an iteration on the screw dial system I was showing earlier. The problem with the screw version is that I need a USB port to come out of the side, so I started trying to figure that out. I started working on ways for the screen to be stationary, but still have some of this screw mechanism. This version has a cutout for the microcontroller and USB port, which is always pointing to the right, because if we put the bezel on, the text is always on the top like this. In theory, the legs would stick through far enough that we could still have a back plate that like screwed in to hold the bezel on nice and firmly, but the legs are too short here, obviously. A lot of those design elements get iterated on in our next versions, and you can see here, if I put the screen in here, that's where the socket for the microcontroller sits perfectly, and there's a cutout for the USB. I have even more iterations after this because the bezel didn't push in right or the back didn't turn right, but we are really close. I think this print that's live right now is going to be it, so I'm going to wait for that and then let's try to put this thing together. All right, real build, let's do it. So in the shell, I put some heat set inserts. That'll give us a nice place to screw the back cover into. If you're not familiar, a heat set insert is basically like a nut designed to be melted into the plastic, so you have a nice solid thing to screw to. Aside from the shell, first piece we're gonna need is our button. That's gonna slide through this tube, and we kind of delicately need to work it in. And then that weirdly shaped, I call it the cork, I don't know what you'd call it, but the button assembly, that goes in and it should match the internal circle perfectly. It was a little proud, it stuck out a little bit here, so I just had to sand the button down a little bit, but then perfect fit. We need to make sure to put in our coin cell, otherwise our watch will not be a watch, it'll be like that monkey, the one who covers his eyes, you can't see, the no watch monkey. Before we put the screen in, we need to wiggle the battery through the shell. There's kind of a small area that the wire needs to run through, so we just want to make sure that's aligned. I'll make sure I didn't accidentally pinch my button wires in there, and then we can screw our screen in. I'll connect our main battery and our button, and now, in theory, the screen should turn on if we press the button. There's no microcontrollers, so it won't do anything, but if we press it, I think it's turning on. Here, let me turn off the overhead light. Yeah, there you go. Obviously on. We have power, looking good. We'll slide the bezel on the front, and you can see as the legs from the bezel come through, they block the assembly for the button, so that's all really solid now. Next, we'll jam our microcontroller in, and it should line up oh so perfectly with that cutout. Now, a professional might use some double-sided tape or something to hold the battery. I think it's not necessary. We can put the cover on, turn it, everything's nice and snug. Then a couple of screws really hold this back firmly against those insets that we added. And there we go. We have a watch all built. I mean, it doesn't actually do anything yet. I got to do some software. We got to design a watch face, and then I got to paint it. But then, okay, bad news, guys. Opposite of we have a potentially project-ending issue. As I was working on the watch face, I was making good progress. We were getting some numbers up on the screen. And, you know, you can press the button, 8 there. So that seems totally fine, right? Like that seems like what we want out of a watch. However, if I take this and I remove our programming cable, now when I go to turn it on, we get that flash. You see that? So, like, in my opinion, like that looks so bad. There's no way I'm gonna call the project done when every time you go to check the clock it flashes. So it's interesting that it doesn't happen when the device is plugged into the programming cable. And I was Googling around, and what I found was some people mentioning disturbances that were happening when powering up versions of the screen. This is a slightly different one, but the hint that this person dropped in this GitHub issue was that there is a command that is sent to turn on the screen, and it seems like that is happening too early, or like before new data is being written to the screen. So the result is that noise pattern. I went into the library I'm using, TFT-ESPI, and I found a boot sequence for this screen, and I found a reference to that command. And it's like right at the very end after a little bit of a delay, which this feels, promising, right? So I think this crazy series of commands happens every time the screen turns on. I have no idea why it's so complicated, but this OX29 might be the culprit. So at first I was like, well, get rid of that, right? That should solve it. So now I just need a way to replace that command I deleted and put it in my code. Then I should be able to control when the screen turns on and make sure that it has data. The next problem I was encountering was that the object I have here, which is called face, because that's what it's called in the example code, there is no command on it to like write, JK, I'm kidding. It is right there. Okay, so if we go write command, and this is after I've done all my initialization code, and we say OX29, and now we try to boot that up. If I unplug it, do we get a flash? And no, we don't. Okay. It doesn't turn on like instantly, but I mean, I think that's pretty reasonably fast. I might be able to speed it up a little bit in other ways. Okay, that's great. That's great news. With that sorted, we can move on to the fun part of designing the watch screen. This background is not done. All the gray parts are just static gray. They'll show up pretty much exactly how they do here. But the thing I want to focus on is these bright colors for the AM and PM. Now, you can imagine if we take that gray and we turn that light blue section gray, then this text says PM. If we alternatively take the orange and turn that blue part orange, then it says AM. I'm trying to design the whole face around toggling on and off sections, just like an old segmented display would do. To do this with the least hassle, I made a little key or a legend in the top left. Then in my code, I associated these positions with toggleable states. For example, AM. So that light blue will turn into the theme color if AM is true, and it will turn into a dark gray if AM is false. Using this technique, we can go and, for example, take that blue, change a bunch of these rectangles to be blue, and now those will toggle to the theme color during the AM. So we could make a much more complicated watch face if we wanted to. If we wanted to add another one, I could pick a new color, go into the code, associate that pixel position with a state like, is it Friday? Then I can go and add more using that color. And now we'll have a big message that says Friday on Fridays. Now in practice, we don't want the word Friday there because these spaces are reserved for the actual, digits of the time. But that's how I'm going to build up the rest of the watch face. As I've been 3D modeling, I've been occasionally painting pieces, so I would spray paint something and look at it and be like, I don't know about that. So like this yellow, it was too bright. So I did what's called a wash, where you thin out paint and try to coat it to get a darker, grimier look. I'm no painter, but I did my best. So let's finally pull all these things together and take a look at my pocket watch. And that's the lock and watch, my friends. Thank you so much for watching. Like everything I've made, the true function here is, of course, to be a cat toy. Thank you for watching. I will see you next time.